OAI exposure system. This system comes with a high wattage arc lamp and power supply. The system should be turned on using 208 three-phase power supply to the lamp power supply. And the system includes a PC with Mac OS. And the PC is interfaced to the shutter in the lamp housing so that the exposure could be made in terms of energy levels. So the dosage, how much energy is desired, can be entered in the PC, and the shutter will open for a few times to achieve the energy level. We have included a digital timer with the machine, which can be programmed from fraction of a second to 999 seconds, or even in minutes and hours. So care should be taken that the lamp housing is properly installed, and the lamp housing should be bolted down using 4 bolts at the base plate. Currently this housing is bolted down to the pallet here. It will be removed, and if it is not properly bolted, there's a chance that the housing will tilt forward. Also, the housing requires a good exhaust connection to vent out the hot gases coming from the lamp housing. And there is an interlock with a vacuum switch which senses the exhaust fan running. And if the interlock is not made, the power supply will never even turn on. Also, there are interlocks on the side covers where the lamp is installed. And if the lamp, for any reason, if the covers are open, the power supply will not turn on. We will include the detailed manual for the power supply in the housing. And not many details exist with the computer. So I'm going to show how it works. There is an application which is listed in the recent applications, OAI 3. This application opens a window, a couple of windows, the console and OAI exposure window. So the OAI exposure window indicates here lamp intensity. So in order to enter the data here, you have to enter the lamp intensity, which is measured at the surface, at the exposure area. So in this case, first press with a return, and now we have to enter the data, lamp intensity approximately 50 milliwatt per centimeter square. Enter the target energy, that is the energy we need to expose on the samples. So this energy could be a number that is desired, for example 100. So once I select that and press return, now enter target shutter speed. So here if I enter, say, we can enter a fraction or even a digit like 10. Now that's a wrong entry for the shutter. It should never be entered like a number like 10. So I'm going to do it again. Say 200, and speed about 1. once we enter this, and we can press escape, to start exposing. So right now I have connected the output of the computer control. So the exposure took place for the desired energy. Let me show you again. Let's change the parameters again. So intensity is 54, which is exactly on this unit. And so I want a target energy 300. And shutter speed we keep it at 1. What is happening is the shutter is opening and closing for a multiple number of times in order to achieve the target energy. This is a system where you want very small amount of energies and you want the exposure to be for very short durations. Say for example, if I only enter shutter speed 25, so in order to get the target energy, the shutter was open for about 0.5 seconds twice. So in order to protect the shutter motor by not exposing for multiple number of times and getting damaged, a digital timer is included with the machine. So the digital timer has a timer here, which is programmable. You can increase or decrease the digits here. The lower digits is the set time, and set duration can be increased. And then this will be the start button. You press start, the shutter opens. For 22 seconds I have set it. And this way the shutter won't open multiple number of times. So this will be included with this digital timer will be included with the machine. And it will help to run the system. So at any point of time, here is another explosion. You can stop it if you don't want to stop it. the digital timer is operating at about, it gives to the shutter about 36 volts DC. 110 volt power is required to be connected to this unit. Right now I'm connecting a DC output from a power supply, and when the system will be shipped, this module only will be including its own power supply with output about 30 to 36 volts. And all you have to do is connect this shutter output to the cable coming from the lamp housing and power. So the computer signal from the computer goes to this module, which is an interface box, and from this box the output goes to this module, which is another box where the shutter power supply is generated, and the output from the computer control is available here, where you disconnect this white Molex connector and connect it here, then it will be computer controlled. I'm going to show some readings here, the energy levels of this unit. I have a meter here with a 365 nanometer detector and a 405 nanometer detector. This detector will not be included with the machine. And the power supply, right now I'm operating in constant power mode. It can be also operated in constant intensity mode, provided it is calibrated. So once you calibrate the intensity level of every sensor using the external meter, so there is a procedure to calibrate this. So you put an external meter and then choose channel A for one wavelength, 365 nanometer or 405 nanometer, and channel B for 365 nanometer. So choose each wavelength, and then you calibrate the meter using, to match this meter here indicates either intensity or power. So right now it is intensity that it is showing here, and then we have to match it. This is about 25 milliwatt, and the analog meter here is also indicating 25 milliwatt per centimeter square, and that's at 365 nanometers. So if you choose channel A, then that will be another. So this needs calibration as well. So it's important to verify that so this is 405 reading about 50 milliwatt per centimeter square on the digital meter, and at 365 nanometer is about 23 milliwatt per centimeter square. So there is no filter. The wavelengths are not filtered in the lamp housing, but both the wavelengths are used or available to expose. So right now I'm going to see I can increase or decrease. If I want to set it at 20, I can set it, and if I want to increase it to 26. So what the system will do is it will adjust the power of the lamp to achieve the desired energy levels. So when the system is not being used, when the lamp is on but it is not being used to expose the sample, it's always better to leave the system in constant power mode at an idle energy level, which is about 70 to 80% of the peak value. So the lamp is a brand new lamp I have installed in this. So the lamp we have is Advanced Radiation Corporation, and I will put the lamp inside this box when we ship it. It's the lamp type number is HSA 2002-30341, and it's a mercury arc lamp. And this lamp has a life. It has a limited hours as per the manufacturer, and once after usage, if the energy levels seem to be dropping, the intensity levels, then the lamp needs to be replaced. So that the lamp has to be installed as marked on the lamp. The lamp has two electrodes, the anode and cathode, and the anode up position. That is, the lamp should be mounted vertically through the ellipsoidal reflector such that the anode is up and the cathode is down. And on the anode there is a heat sink, which I will also include it inside this lamp holding case. And the heat sink has to go first on the lamp, and then you connect the electrode wire hanging, a braided wire is hanging in the housing, and then use the thumb screw to tighten the cap and the electrode down. So for the lamp housing cooling, I have used my in-house exhaust connection. And this exhaust connection is slightly on the edge, it is on the lower side. This is the vacuum switch. I have jumpered it because my exhaust fan is not strong enough. So when we connect this system, before even turning on the lamp, once you connect your exhaust, and I will leave these two wires connected to the vacuum switch. So the lamp, you have to make sure that the two connections are on this side of the vacuum switch, on the side here. And we have to make sure that there is a continuity between the two pins here. So the lamp housing gets really hot if it is kept running. So exhaust is very important. The lamp exhaust should be on. Sometimes even after turning off the lamp. So there are connections here. This is the interlock connection cable, and the shutter power goes through this. And also these are the lamp electrode wirings. One goes to the cathode, one goes to the anode. And there is a interlock connector here. And the anode and cathode are color-coded. Black is for cathode, red is for anode. And this is the detector feedback. And there's also a 120 volts AC output available from this lamp power supply. Right now I have placed the power supply on the left hand side of the power supply. There you can see two cooling fans for the power supply. It would be ideal to locate the power supply to the right of the lamp housing so that the cooling exhaust fans are not covered. Anytime a lamp is replaced, using protective goggles for UV radiation, yellow goggles. These are the goggles we recommend to wear while operating this machine. And wearing these goggles, turn on the lamp, and the lamp requires about 10 to 15 minutes. A good 15 minutes or 20 minutes time will be good to warm up the lamp so that the intensity will stabilize. And once the lamp is energy is stabilized, you can see that on the power meter for the lamp power, it will be stable, and the current and the voltages will be of the order of 63 volts, and current will be about 31.7 or little over 30 amperes. So if you are running the lamp at less than 2000 watts, the current will drop a little bit. And these are the knobs. There are two knobs, 1 and 2. These two knobs will adjust the position of the lamp in XY plane. Whereas this big wheel here, it will lift the lamp up and down. The purpose of these knobs is to exactly locate the arc inside the lamp at the focus of the ellipsoidal reflector. This is the ellipsoidal reflector. The arc in the arc lamp should be at the focus, at the tip of my finger, around that location. So by moving the lamp up and down, the positioning of the arc can be adjusted. By using an external meter and keep leaving the shutter open, we can see how the intensity level will peak up when the lamp is exactly at the focus. Let me show that. Okay. This is the meter. Moving the knob, the Z-axis knob, it is decreasing. I'm moving in one direction, and if I change the direction, the reading heats up. And at certain point of time, it will start to decrease. So that's when you bring it down. So the way the lamp can be adjusted and the uniformity can be achieved is by moving the other two knobs, and the uniformity is measured at the different. So if we position the detector at different points and see it is uniform along the x-axis and also along the y-axis. So there's in the user's manual there's a formula how to calculate the uniformity. Typically, the lamp uniformity can be achieved better than less than 3 to 5% with barely adjusting these positions. So you can see the reading will start to jump. So the knob should be moved very slowly, cannot be moved fast. So the unit will be shipped after thoroughly cleaning it and painting it. And another thing to notice is this plexiglass here prevents exposure to the unwanted UV radiations. So it's important to leave the shield on unless a big item is to be placed inside. In that case, I recommend to use thumb screws in place of these Allen screws and use the system.